Okay, this is term 1, week 10 mechanics. It's very, very easy. No, actually, it's not very, very easy. It is very, very easy. But at the same time, it's a bit hard at the same time. You just need to understand. So, look, you can go through the notes. I'll go through the quick things, or I'll go through the formulas that I want you to understand. Okay, أول شيء Newton's third law. You should know. They will ask you what is Newton's third law, and it's for every action there's a reaction. And what is that reaction? أول شيء you need to know that it's equal in magnitude. It's on the opposite direction, and it doesn't act on the same object. So let's say this is the action. FAB. There shouldn't be a negative here. This doesn't mean negative. I wrote this here as like a dash. Okay, FAB is equal to minus FBA, right? Because it's the opposite. Okay, these are very important points. You should know that the two forces, the action and reaction, cannot be added. You should know that they don't cancel out. So that means the net force, it doesn't equal zero. Okay, the net force does not equal zero. They only cancel the effect of the force. Okay, like مثلا if you have a book on a table, there's going to be weight of the book, and the reaction of it would be the normal reaction. Okay, and we call it normal push. They just cancel out the effects, but they don't cancel out like algebraically. So this weight will still be going down. This will still be going up because they act on different objects. You will need another force to change the motion of the object. Okay, these are just points because they were questions I saw. Okay, that could come. Okay, this was in the book and it's a learning point, but it wasn't in the quiz. Thrust. Okay, planes, cars, boat all use Newton's third law to move. Okay, they push something backwards and that something pushes the object forward. That's how it works. So, for example, rockets in space, how do they move if there's nothing for them to push against? What they do is they release oxygen gas to burn with other gases to produce highly pressurized gases that push the rocket forward. So, they push gases down, and what do the gases do? They also push the rocket up. That's how they move in space, because you're supposed to push against something, and that's what to push on you. مثلا cars, they push on the ground. The tires push on the ground, and the ground pushes the car front in turn. Same thing with the rocket. It pushes gases down, the gases push the rocket up. Okay, very simple. They could get any what is the what law does how do in what law do rockets use for them to move? You can say Newton's third law. Friction. Okay, friction is very important. You should know it's a contact force. Okay, when objects slide against each other, it's called kinetic. So if it's moving and there's friction, it's called kinetic. If they don't move, but it's like the thing stopping it from moving, there's a friction force stopping it from moving, we call that static friction. These are questions that could come multiple choice, but you don't need them for solving. Okay, you should know that it also depends on the nature of the surface, and if it's rough, if it's smooth, whatever. All objects, no matter how smooth, have some rough edges. Okay, you should know this. If the body is not moving, then the friction is called static friction. And if it's moving, you call it kinetic friction. So you should know these are the three stages. Let's say the body is not moving, then this force is equal to the static friction, right? Because it's not moving, so the friction is canceling out the force. Let's say you're pulling an object, okay? You're pulling an object, it's not moving, you're pulling it, but still not moving because the friction is opposing it, right? The friction is opposing it, so that means the friction is equal to the force you're pushing. Let's say the body, this should be less than, this should be less than. Uh, oh, no, actually, no, this is correct, yeah. Now, when the body is about to move, so it's on the inside, so if you put one more Newton of force, it would move. We call that the maximum static friction, Fs max. And obviously, if the body is moving, the force you're applying is greater than the static friction it has, okay? Because the static friction will cause it not to move, and if it's moving, that means the force you applied was greater than the static friction. Okay, you should know, what's this? Oh, this is just an object. Oh, no, this is, yeah, you should know this. F net x is F minus Fk ma. As you apply an object, as you apply for, okay, yeah. So yeah, this is just a graph. So basically, the more force you apply, the more kinetic friction there is. Until خلاص, the more friction there is. Until خلاص, it reaches the maximum friction, right? That's when the object starts moving, and what happens to the friction? It drops to kinetic friction. Usually, kinetic friction is lower than static friction. This is just like imagine you're pulling an object. There's so much friction opposing the motion until خلاص you broke the barrier of friction. خلاص it snaps and the object starts moving and it reaches Fk. It goes up to Fs max, it's the maximum static friction, then it goes back down to Fk, kinetic friction. Fs max, this is the formulas you need to know. Okay, yeah, this is static friction is greater than kinetic friction. know this. Static friction is equal to mu times n, mu s times n. Kinetic friction is mu k times n. They're always given in the question. Sometimes they ask you to find it. Say, we're going to see questions like this. Uh, whatever, okay, you should know that the mu's are always in between 0 and 1. They can't be greater. In cars, they use the fact that static friction is greater than kinetic friction to design brakes. They use anti-skid brakes where the wheels don't skid, so they use static friction, whatever. These are like cake stuff you can know. We're done with the notes. Very easy. Just know this. Now something I'm going to explain because you're going to need a lot in the solving. You should know Newton's first law is sigma of x is equal to 0. This is for an object not moving horizontally. And then sigma Fy is equal to 0. It's good to put the arrow. Is when an object is not moving vertically. Right? When the net force is 0. How about if the object was accelerating? No, not if I'm saying accelerating, not constant velocity, huh? If it's accelerating. If it's accelerating, then sigma Fx would equal to ma, and sigma Fy is equal to ma. But you should know that sometimes you can have مثلا the object is only moving in the horizontal sense, but it's not moving vertically. So you'd say sigma fx is ma and sigma fy is 0. These are two important things you should know. The second thing that I'm going to use for every question I'm going to solve in the quiz is the free body diagram. The free body diagram helps you in solving so much. Okay, basically you represent the object by a point. Yeah, so the free body diagram, you represent the object as a point and you list all the forces. It's a good idea to start drawing like this. You put like this, y, x. Oh no, you put x here. Free body diagrams in your written part, and they will come in your written part, whether it's periodic, whether it's final, you're going to get a question that has to do with a free body diagram. You need to solve. So what you need to do, I solved the whole poly. After you get, this is the hardest step of the question. After you get free body diagram, خلاص, you can solve everything. Okay? مثلا, let's say you have weight. If it's an inclined plane, you should know that weight, I'll draw it in red. If it's an inclined plane, you should know that weight acts at an angle. But the normal reaction always acts up. This is مثلا for an inclined plane. Let's say it's a car accelerating. You'd have the weight. You'd have, let's say this is the normal. You'd have, by the way, I drew this wrong. Weight and normal, usually, if it's not going up or down, that means the length of the arrow of the weight should be equal to the length of the arrow of the normal. Obviously, we're not going to measure it with a ruler when correcting the teachers, but make them look equal. And if they're forces that you think are equal in magnitude, then make them look equal. Let's say it's a car moving, so it's accelerating to the right. You would say, مثلا, draw this, always put A right, or if it's accelerating to the left, you would say A to the left. This is how you write acceleration. You'd say, since it's accelerating, you guys know there's always friction. And since it's accelerating, we call it Fk. And the force at which it's accelerating. This is how you draw a typical free body diagram. Now we're going to start solving. The questions may seem hard, but once you get it, it's very, very easy. Okay? Over here, you have, this is a car or a trolley. Okay? A trolley accelerating towards the right. Okay? So this trolley here is accelerating towards the right, with a mass m placed against its vertical front surface. So it's moving to the right, and this block m, we want to know what's the acceleration that the trolley should have for m not to slip, knowing that the coefficient of static friction is 0.4. So they gave us that mu s is 0.4. Here's what you do. And you should know that أكيد, what's stopping the block from moving down? It's the friction, right? So what do we always do? The first step for anything is always draw the FBD, free body diagram. Of what? Now we're talking about the block here, of block. Let's see, what do we have? We have our block. Always start with your weight. صح? Wait. طيب, what's stopping the object from going down? It's the static friction. We're going to draw static friction. Now we know that the object is accelerating towards the right. Anytime you have weight, you should have a normal push perpendicular to the surface you're acting on. Here, the surface is the trolley. So since the trolley is here, the normal reaction, you'll always have it perpendicular to it. So this is N. Now you drew your FBD. I can't think of any other force. Obviously, we have our friction, we have our weight, and we have our normal that's perpendicular to the trolley. Let's see. You're going to now check your vertical and horizontal. Our trolley. Let's start with vertical, Fy. Is it going to be equal to 0 or ma? Let's see. Is the object moving? Is my object moving up and down? Is it accelerating up or down? No. It's not slipping. So it's staying up. It's not moving. So it's not accelerating. So what's sigma Fy going to be equal to? 0. So here, the sum of all vertical forces will get to be 0. Right? So let's start with weight minus. Why minus? Because it's in the opposite direction. So minus Fs is equal to 0. So in other words, the weight is equal to Fs. This is always your first step. Let's see, now check your horizontal force. Always FBD, vertical force, horizontal force. What are my horizontal forces? I asked myself, is it accelerating? Is it not? We said it's accelerating. So what does that mean? It's equal to ma. Right? What is my only horizontal force? N equal to ma. Now, we're going to do some substitution. W is equal to mg. G is 10, so we're going to substitute it with 10m. So 10m is equal to Fs. What's Fs equal to? Fs is equal to mu n. صح? Okay. What is mu? 0.4. So Fs is equal to 0.4 n. So 10m is equal to 0.4 n. Remember, we're trying to find the acceleration, right? What is my acceleration equal to? Take m to the other side, divide by it, you get n over m. Don't I know what n is? I can know what n is if I just take 0.4 to the other side. N is equal 10 over 0.4 m. صح? So we're going to change it. 10 over 0.4, by the way, is 25 m. So you're going to go to A. It's going to be 25 m over m. Cancel, cancel. A is going to be equal to 25. Question 2. Okay, these are easy multiple choice questions. A body A exerts a force on body B, denoted by FAB, and body B exerts a force on body A, denoted by FBA. Which is true? FAB is the body A on B, and B on A is BA. Which of the following is true? Of course, we know that these are action-reaction forces, right? So FAB is equal in magnitude to FBA. Are they the same direction? Absolutely not. They always have opposite directions. And action and reaction forces act on different bodies. Of course, they do not act on the same body. Question 3. Okay. This is very easy. A cyclist of mass 70 kilos has and they gave you its acceleration. So they gave you the masses. They want the net force on the system. They said system. So what's the total mass? 85 kg. Acceleration 0.8. F is equal to ma. So 85 times 0.8. So 68 newtons. Question 4. A person is pushing a cart with a force 50 newtons to the left. The cart exerts on the person a force of magnitude obviously 50 to the right. Because action, reaction, right? Opposite force, equal in magnitude but different direction. Question 5. This one, بدأت شوية تفكير. A particle of mass 5 kg is projected at 3 meters per second up a rough inclined plane at 37 degrees above the horizontal. The coefficient of friction is between the particle and the plane is 0.3. Use G equals 10. So remember, now they're saying the force of friction, the magnitude of acceleration. Guys, if you want to solve these types of questions, always, I tell you, draw FBD. The FBD here, what's it going to be? Inclined plane, many students get it wrong. The weight will be this way, right? But you have to know that it's not gonna look like this. No. Why? Because it's inclined plane. How I like to do it is I draw the normal, I draw extend it, I draw the x-axis. This is y, this is x. Draw the weight. It's gonna be like this. Well, okay, what's the angle here gonna be? 37. So let's draw it. I don't like solving like this. Many teachers solve like this. I don't like. I redraw it. Y, x. Weight is here. Okay. What else do we have? We can see here the we have. I'll draw in a different color. Blue. You have the normal, like this, and we have friction, right? Because the ball wants to go up. It's trying to go up, so obviously there's gonna be Fk here, right? Let's see. We want to know the force of friction of the particle. What did I tell you always you do? You start with your vertical component and your horizontal component. Let's start with the vertical. Am I moving up or down? No, I'm just moving left and right. So obviously it's going to be 0. What are my vertical forces? You have N and you also have Wy. Here, weight isn't a vertical component. Why? Because it's acting at an angle. So it has its X component and it has its Y component. Okay? So N equals Wy. Or you know what? Let's make it a bit easier. N minus Wy is equal to 0. So N is equal to Wy. And what is Wy equal to, guys? It's W cosine 37. Some people tell me, why cosine when isn't it sine? Look, because the angle here is with the vertical. When the angle is with the vertical, you swap. Y becomes cosine, X becomes sine. So this is our first thing. So what's our second thing? Our horizontal. And it's accelerating. It's moving to the left, right? So what's it going to be? MA. Sigma fx is equal to MA. What horizontal forces do I have? I have Fk and Wx. So Fk plus Wx is equal to mass times acceleration. Let's do some substitution. Fk, what is kinetic friction equal to? Mu k times n. So mu k times n plus Wx, what is it? It's going to be W sine 37 is equal to mass times acceleration. Mu kn. Let's substitute. W cosine 37. What is weight? W is mg. So n is equal to mg cosine 37. What's mg? 5 times 10, so 50 cosine 37. Okay. Fk, it's mu kn, right? What I'm solving here is for part A and B, huh? Because it's also part B step. Mu kn, what's mu kn? Mu k is 0.3. N is what? 50 cosine 37. Plus W sine 37 is, by the way, is mg sine 37, right? Because W, like we did here, is mg, so 50 sine 37 is equal to ma. What's the mass? 5a. Because you need this for part B. Before we continue and solve this to find A, what do they want? They want the friction. They want friction, so they want mu kn. So what is it? 0.3 times 50 cosine 37. 0.3 times 50 cosine 37. You get 12. Can I find acceleration now? Of course I can. So acceleration is going to be 0.3 times 50 cosine 37 plus 50 sine 37 over 5. I think, let me see. 0.3 times 50 cosine 37 plus 50 sine 37 over 5. 8.4. The distance traveled by the particle before coming to rest is how much? Let's see. You have the particle we know it's accelerating at a equals 8.4. What's the distance traveled by the particle? I have v node. We want to find x. What formula from UARM has a, v, and x? V squared minus u squared, let's call it v naught squared, is equal to 2ax. We know it started at rest, right? And it's obvious it's starting at rest. So v squared, it stopped, it came to rest. Its final velocity is 0, not it started at rest. It started at 3, so v naught is 3. So this is 0. So minus v naught squared is equal to 2ax. Before I continue, I should have gotten a is equal to negative 8.4 because a is acting to the left and the forces here were acting to the right. Okay, I should have gotten a is negative, and because they said magnitude, I put it as negative 8.4. I put it as positive because they said magnitude. So minus v naught squared. So minus how much is v naught squared? Is minus 9 because 3 squared is 9 is equal to 2 times minus 8.4 x. So we're going to divide minus 9 by 2 times minus 8.4. You get 0.5. Okay. Then they said after the particle reaches the highest position in the plane, it begins to slide down. The magnitude of the new acceleration is a2. Complete the following from the table below. This one you can use logic. Obviously, when you have a ball at the top and it starts moving to the right, from the top, it's obviously going to accelerate from the top faster than it goes down because it's not going against the weight, right? The weight is going to pull it down. So it will obviously accelerate faster than it accelerated going up. That's just using logic. You can use a different method, whatever. But I'm using logic. It makes sense. Two particles of A and B masses 2 and 3, respectively, are connected by a light extensible string. Inextensible string means A is equal to A. A1 is equal to A2. I'll show you in a second. Particle A rests on a smooth surface. B, whatever. I'll show you here. A is 2 kilos. B is 3 kg. Okay. The system is released from rest and accelerates at 4.5 meters per second squared. So A is equal to 4.5. Take G equals 9.8. What's the tension? Okay. I'm going to draw two FBDs. Okay, two FBDs. I'm going to start with block A and then block B. Block A always start with weight. Up, normal. Right? There's a string. So what forces are going to be? Tension. So the tension is going to pull it to the left. Let's see. This is block A. How about block B? Block B, it's an inclined plane. So what do we do? You draw it slanted, right? You're gonna draw it slanted. The weight is like this, but the normal is going like this. صح? So you're gonna draw it like this. And the weight is gonna be to the left, right? So let me just complete this over here. Why did I put it under X? Okay. Type. Obviously this is how we have its weight, and it's the normal reaction going up, right? Let me draw it in a different color. So normal هيك. And we obviously know the tension is pulling it to the right. And we also have WX, WY. صح? طيب, let's see. Here, block A, it's going to be moving to the left. صح? Let's start with sigma Fy. Is it 0? Yes, because it's not going up and down, it's just going to the left. صح? So it's going to be, what are the two vertical forces? W is equal to N, so N is equal to mg. How about sigma Fx? It's going to be equal to the mass of A times the acceleration of A. What are my horizontal forces? Tension. So there's nothing other than that. Tension is equal to the mass of A times the acceleration of A. How about block B? Sigma Fy. Is it moving up and down? So no. Again, 0. So Wy is equal to N. So W, what is it? It's mg Wy is gonna be cosine, right? Because it's for inclined planes always swapped. So cosine theta is equal to n. Sigma fx is equal to m of b now times the acceleration of b. What are my horizontal forces? T and wx. Since it's moving to the left, right? They said it's going to be accelerating. Wx is greater than t. So always, and I write it like this. Wx minus t because it's in the opposite direction. But which one do you put first? Which one? Wx or t? And I always say it's going to the left. So Wx, since it's going to the left, which force acting to the left? Wx. So that will be my bigger force. So Wx minus t. I put Wx first, then minus t. Is equal to mass of b, acceleration of b. And then substitute a bit. What's Wx? It's mg sine theta minus t equals mb acceleration of b. Okay. The tension. Now we have these two equations. This is for block A. This is for block B. Okay. So part A, can we find tension in the string? Yes. Tension is equal to the mass of A, which is 2 kilogram, times the acceleration 4.5. Walid, could we have just used for 2 F equals ma 2 times 4.5 is 9? Yes, of course, yes. But for part B, you're gonna need this part. طيب, انت now you have tension. It's 9. Can we find what theta is? Yes, we have this equation with theta, right? So let's see here. mg sine theta. The mass, here we're talking about what? B. So we have to say, I have to specify B. I should have written B. B, what's the mass of B? 3. What's G? It's 9.8 sine theta minus 9 is equal to the mass of B, again 3 times acceleration of B, 4.5. Can we find, this is 9. Can we find theta? Of course we can. Just simple now calculation. 3 times 9.8, 29.4 sine theta minus 9. 3 times 4.5 will be 13.5. So take it to the other side. So plus 9. So you're gonna have this, right? 22.5. Divide by 29.4. You're gonna get this. Since it's sine, what do? We do shift sine 49.9, which is 50 degrees. Question 7. Two particles of respective masses m and 3m are connected by an extensible string S. So that means if its tensions are equal. Okay, inextensible means on the left is equal to the right. Pulled by a force F along a rough horizontal forces, the system accelerates at 6. The coefficient of friction is 0.6. So mu is 0.6. Use G equals 10. The tension in the S is Pm, and the magnitude of the force is Qm. What is P? So, okay, they want you to find the tension first, okay? How do you find the tension? Again, draw free body diagram. Let's call this A, let's call this B. A obviously has its weight, which is mass times G. I'm going to call it mg. And obviously has normal up, right? It's acted by a force to the right. What force? Tension, because it's a string. And it's pulled on a rough surface, so it should have friction, right? طيب. Block B. Down, it has its weight. But since it's 3m, it's going to be what? W is equal to mg. What's its m? Its mass, it's 3m. So 3mg. It has normal reaction. It's being pushed by a force F. And it's also being pushed by the string. And then it has friction. صح؟ طيب, let's see. Let's start with block A. Fy. Is it going up and down? No. So mg is equal to m. Well, let's call this block A. Let's substitute from now. No, actually you can't. ma G is equal to M. That's our first equation. Let's try now fx. Is it moving left and right, or is it at rest? It's moving, right? Because it's being pulled. So it's equal to M, let's call this block A, times the acceleration. What horizontal forces do I have? T and F. Since it's moving to the right, T is greater than F, so I'm going to call it T minus F is equal to the mass of A, which is just M. Let's just call it M. A. Let's substitute now. What is friction equal to? It's mu N. What's mu? It's 0.6. What is N? It's mg. So T minus 0.6 times mg. What is G? G is 10. So I'm going to put it as 10. Equal to the mass. We know it's m, right? It's just mass, right? They said the mass is m. The acceleration, what's the acceleration? 6. What's it going to be? This is going to be T minus 6m is equal to 6m. What's T equal to? 12m. So what is the tension? It's how much? It's something m. What's that something? P. 12. Easy. Second block. This is for block A. This is block B. Sigma Fy. Is it going up and down? No, so it's 0. What vertical forces do I have? I have N and I have 3 mg. So N is equal to 3 mg. طيب, how about Fx? We know it's accelerating to the right? So that means F plus the, should be, well, I don't know why I put it as F. This is tension, because it's from the rope. So F plus the tension minus the friction is equal to, oh no, I should have just written yeah. Fx, since it's accelerating, it's equal to ma. So what's my sigma fx? F plus t minus F. F plus t minus F is equal to the mass times acceleration. Substitute. F t is 12m minus F. We don't know how much the friction is, but what we know that friction is equal to mu n. What is mu? It's 0.6 from the question. N, what's it equal to? 3 mg. 3 m. What's g? 10. So 6, 18. So you're going to get 18m. So F plus 12 minus 18m is equal to m. What's the mass of this object? It's 3m times 6. So you're going to get F plus 12m. I made a mistake. I'll show you what I did. Minus 18m is equal to 18m. So you're going to get F is equal to 18 plus 18, 36. 36 minus 12 is 24m. Why is this wrong? Let me tell you why now. I should have put minus t because it's in the other direction. The rope is pulling it, resisting it to the left. I should have put, yeah, you're pulling the string with a force to the F. The string will resist that force by pulling the object back to the left with the tension. So the tension shouldn't have been, let me just erase this and draw another one here. Like this. So it should have been minus t. So instead of plus, minus, horn minus, minus, minus. So you would get now 48m. Question 8. A body of weight 30 newtons lies on a rough horizontal table. The body is gently pulled to the side using a string inclined at 30 degrees to the horizontal. The tension in the string is 18 newton. Assume that the body moves with a constant velocity. Constant velocity. So A is 0. No acceleration. This is important. Again, let's draw the free body diagram. Its weight is 30 newtons. So weight, let's just put 30. The body is gently pulled to the side using a string inclined at 30 degrees. So what? The string, the force like this, 18 newtons. And how much is it? 30 degrees. How much is the friction exerted by the table on the body? We know that it's being pushed to the right, yeah? And they said something. They didn't say friction? Yeah, they said it's rough. So what does that mean? There is friction. So we have our free body diagram now. It's being pushed to the right, there's friction. How much is the friction? Let's see. Let's start. Anytime you have this, sigma Fy, is it equal to 0 or accelerating? 0. We didn't say it's going up and down, so it's equal to 0. What are my vertical forces? I have the 30, and I also have the vertical component. I'm going to draw the Y. And I'm going to draw also the X. What is the vertical component of this? Can't I find it? Yes, it's going to be 18 sine 37. Right? So let's call this, مثلا, let's call this tension. I'll put T and 18 newtons. So you're going to have, put here, we're going to resolve it into Tx. And up here, Ty. So Fy, Ty, whatever. What are my vertical components? The weight, let's call it weight, and Ty. They're equal. When it's equal to 0, that means the two forces, opposite forces, are equal to each other. W equals Ty. What does this mean? The W, 30 newtons, equal to Ty. What is Ty? It's 18 sine 30. What did you sign this time? Because this time the angle is actually with the X. Previously it was with the Y axis. Okay, 30 is equal. Wait, I made a mistake. I didn't draw. I forgot, guys. When drawing, sorry, very sorry. When drawing your free body diagram, if you have weight and you have a surface, of course, there should always be a normal force, right? So here, 30 is equal, let's say 30. I won't put them equal to each other. 30 minus n minus ty is equal to 0. In other words, the what's down is equal to what's up. So 30 is equal to n plus ty. Okay? So 30 is equal to ty is 18 sine 37 plus n. So n would be 30 minus 18 sine 37. This is Fy. How about Fx? Is it accelerating? It's not accelerating. We said A is 0 because it's a constant velocity. Many people say, oh, it's moving. يعني شو Fx equals ma. No, it's equal to 0. We only have to have an acceleration. Here ما في acceleration. What are my Fx's? Tx and Fk. It's moving to the right. يعني Tx minus, let's call it Fk, is equal to 0. Tx is 18 cosine 37 equals Fk. What is Fk going to be equal to? 18 cosine 37. So 18 cosine 37. Let's do it on a calculator. Wait. Where did I get 37 from? Why? Why am I saying 30? It's supposed to be 30. Very, very, very. It's supposed to be 30. Why am I using theta as 37? I don't know. What's عادي. 18 cosine 30, it would be 15.6. So the friction, Fk, is 15.6. And for part B, for the normal force, you can easily find it since, like I told you, if you want to do step by step, you can go step by step. But the way I solve, I find sigma Fy, sigma Fx, بسرعة. I always do this because when you do this, خلاص, you got the whole question solved. Okay, of course, read the question before you do all this. But because sometimes it might ask you some easy steps. Like you can do them very easily. But here you can, if you resolve it into components, عادي. Easy, very fast, you can solve. Okay, so normal would be 30 minus 18 sine 30. 21. Question 9. A cart moving along a rough surface will stop eventually. What force makes it stop? Of course, friction. And what does friction convert the kinetic energy to? Obviously, thermal energy. Guys, this is a very easy stuff. Question 10. A block of mass 5 is pushed along a rough horizontal surface. The coefficient of friction between the block and the surface is 0.3. The pushing force needed to accelerate the block at 4 meters per second squared is what? Free body diagram. Weight. Normal. Right? It's being pushed. So it's going like this. Acceleration is to the right. It's pushed. Let's call it force F. Okay, and it has friction because it's rough. Can we solve this? Of course. Let's start with Fy. What's it equal to? 0. Because is it going up and down? Is it jumping up and down? Obviously not. Sigma Fy equals 0. So what are my vertical forces? W is equal to N. What is W? It's equal to mg. So the mass 5 times g 10. So we can just 50. So N is equal to 50. طيب, this is Fy. How about sigma Fx? Isn't it moving at accelerating? Yes. So it means it's equal to ma. What's Fx? It's moving to the right, obviously. So what do we do always? F minus Fk. The bigger one minus the smaller one. Equal to ma. What's the mass? 5. Acceleration is 4. 20. Force minus Fk. How do you find friction? It's mu n, right? Mu kn. What's mu k? 0.3. The normal force, 50. So F minus, this is 15, gets you 20. So, whoa, not 20. 4. Whoa, I'm very, شوفي يا أخي. 4. Acceleration was 4. So F minus 15 is 20. F is equal to 35. Question 11. A lamp hangs down by the ceiling from a chain. If the action force is the upward pull of the chain on the lamp, then the reaction is what? Downward. By who? The lamp on the chain. صح. Question 12. Two blocks of masses MP 400 and MQ 200 are connected by a compressed spring and released from rest. The spring is deformed by 5 centimeters and the spring constant is 200. What is the ratio of the initial accelerations A and P? Here's what you do. Enter, you know F is equal to ma. We need to compare the acceleration. So it's acceleration of, let's call this block P, would be equal to the force of P divided by the mass of P. And the acceleration of Q is force of Q over mass of Q. Right? Let's find the accelerations and let's find, and then divide them and let's see what is the ratio. Let's see. Hooke's law. F is equal to the spring constant times the deformation. What is K? 200. X, the deformation, is 5 centimeters. It must be in meters, so 0.05. And you're going to get 10. Okay? So F is 10. So acceleration of P would be 10 divided by the mass of P, which is 400. Acceleration of Q would be the force 10 again, over the mass of Q, which is 200. If now you put acceleration of P divided by acceleration of Q, you're going to get 0.5. Look, 10 over 400, you get 0.025. And you have 10 divided by 200. So if you put them over each other, 0.025 over 0.05, 0.5. Part B. The graph. Over here, they give you a graph of x with time. We know F is equal to kx. يعني if x is decreasing, يعني أكيد what's gonna happen to the force? It's also gonna decrease with the same relativity. Let's say that. The magnitude of the force of the spring exerts at t equals 0.5 is how much? Okay, so they want the force at t equals 0.5. How much is it? Go to 0.5. How much is it? It's used red. So it's gonna be here 3.8. I think you all know how to find why it's 3.8 because it's 1 in total over 5 blanks. So each blank is 0.2. So 0.2, 0.4, 0.6, 0.8. So 0.8. So x is equal to 3.8 centimeter. F is equal to kx. K in part 8 was 200. بديش أطلع. بس x is how much? 3.8 centimeters. In meters. It has to be in meters. Multiply this, you get 7.6. Question 13. An 800 kilogram car M experienced a head-on collision with 1,500 car N. Compare the magnitudes of force experienced by the cars in the collision. The force on car M is equal to force on N. Because M experiences a force on N, which is equal in magnitude to the force of N on M. صح? Because of Newton's third law. Remember Newton's third law, action reaction. Which of the Newton's law? Newton's third law. Compare the magnitudes of the deceleration of the cars. Deceleration of M, of course, is greater than decelerator on N. You guys know that A is equal to F over M. So for car M, the mass is less than N. So the denominator is less. So obviously the less the denominator is, the more the acceleration is, right? So M would obviously have a greater acceleration than N. Okay? Which of the following can explain your answer? What do we use? F equals ma. So Newton's second law. Question 14. A block is pulled by a horizontal thread across the floor. The tension T in the thread is 5 newtons. The block has a mass of 2 and it's accelerating to right at 1.2. Okay. No calculations needed here. Just read the question. Obviously, the weight is going down. The tension is pulling it to the right. Friction is obviously put to the left. The normal reaction is always upwards. Not upwards, perpendicular to the surface. The force that the tension reacts to the string. What's the reaction force is? If the string to the if the force of the string is 5, what's the reaction gonna be? 5. Oh my god, too hard. How many questions? 20. Oh, okay. A block is pulled by a force meter across horizontal floor. The resulting acceleration of the block and the force to pull it are recorded and presented in the geographical form below. What is the force of friction to 1 decimal place? You can see that it only began to accelerate after the force of 1.5 newtons. How do you know how much the friction is? If you remember in our notes, I drew this graph just to show you that as force increases, friction increases until it reaches a maximum static friction. And then when it starts moving, that's when the acceleration begins. So the friction that when acceleration begins is the kinetic friction. And that's what they say. When they want the force of friction, they're asking for kinetic friction. How much is it here? How much is the forces? How much is the force of the friction? 1.5. Okay? Because the force at the instant of when it begins to accelerate is 1.5. Because here this is 1.2, 1.4, 1.6. In between 1.4 and 6, it's 1.5. The mass of the block. F is equal to ma. At any point, take any point. Let's say, I want an easy point. I can't find a good point. Let's try maybe this one at 2. Let's try 2. Okay, 2. The force is 2. The mass would be, I'll say the acceleration would be 2.5. Okay, what's the mass going to be equal to? Force divided by acceleration. So 4 is 2 divided by 2.5. I did something wrong, definitely. 2. Yeah, so what I did wrong, it was sigma fx is equal to ma. What is this? The net force? Nana, I have the force here. Why did they ask me to find friction in part A? You know why? Because let's look at the block. Again, this is why I always study draw FBD. You have the weight, you have the normal reaction, you have the force, and we have friction. We found friction 1.5. What's the sigma fx? It's the force, which we said is 2, right? Minus the friction, which is 1.5, equals to the mass times acceleration. What's the mass? Mass is, we don't know it, right? We're trying to find it. Acceleration, which we said is 2.5. So it's going to be 2 minus 1.5, 0.5, divided by 2.5 is equal to m. So 0.5 divided by 2.5, you do it on your calculator, it's 1 over 5, which is 0.2. The coefficient of friction given to 2 decimal places. Friction is equal to mu n. In this case, you know that sigma Fy is equal to 0. I should have drawn the FBD for you from the start, guys. Sorry, huh? Sigma Fy is equal to 0. What forces do I have vertically? It's W is equal to N. What is my weight? It's mg. What's the mass? 0.2. G is 9.8. Ya Allah. You can just make it 10, man. Why? 0.2 times 9.8. 1.96. So, N is equal to 1.96. So, mu, we want the coefficient. We have the friction 1.5. We have the normal 1.96. So 1.5 divided by the answer. So 0.77, 2 decimal places. Question 16. The block of mass 300 is held in place on a smooth inclined plane by horizontal force F equals 10 newtons. The angle at which the inclined plane is elevated is how much? It's very important that you see that the block of mass 300 grams is held in place. What is holding it in place? This force here. Let's draw the FBD. Weight, since it's an inclined plane, the weight will look like this. Right? Let's draw the y-axis. And oh dingus. Let me rewrite this. You have y and you have x. Weight is going to the left. Theta. Let's call it alpha. Okay. We have now let's draw the forces. We have obviously W x, W y, and we also have a force pushing it to the left. And we have the normal reaction. Let's see now. We have, is it going up or down? No. So sigma Fy is equal to 0. So that means N is equal to Wy. And what is Wy? It's W cosine theta, which is what? What's W? Mg cosine theta. Okay? Or alpha, or whatever you want to call it. How about sigma Fx? What's Fx? We only have two forces acting. Since it's not moving, what's it going to be equal to? 0. Right? So that means F plus Wx is equal to 0. What's my F? It's 10. What's my Wx? It's W sine theta is equal to 0. W sine theta is equal to 0. That means 10 is equal to minus W sine theta. What is W? Mg. So 10 equals minus mg sine theta. Substitute. What's the mass? 0.3. So minus 0.3. G is 10 sine theta. So that means sine theta is equal minus 10 over 3. I don't know why I feel like this is wrong. Shift sine 10 over 3. Oh. Guys, I just realized why this is wrong. Okay. It's such a stupid mistake. I just drew the forces a slight bit wrong, okay? Let me redraw the free body diagram. In red. Okay, this is the x-axis. Oh, I mistakenly, this isn't my mistake, but this is also a mistake. The weight is going like this. This is the normal, right? So it should be to the right. So here's alpha. Okay. But here they said it's a horizontal force. This is an inclined plane. So if there's a force like this, it's actually making an angle as well. So it's making an angle. It's making an angle. And this angle is equal to the angle that we're using for the weight. It's equal to it. I can prove it for you because these are parallel. So this angle, alternate interiors are equal to each other. So this was the angle of this force 10. It will have an angle. Sorry, in the opposite direction, not this direction. Because it's being pushed to the left, right? So it's going to be alpha. Okay. Hello, we can solve fx. So this is this force F. So okay, there's Fx here, Fy here. What are my vertical horizontal forces? Fx and I should have written Wx. Fx and Wx. So Fx is equal to Wx because they act in opposite directions, right? When it equals 0 and you have opposite forces, they're equal to each other. Fx also is equal to, it's F cosine theta, right? Why is it cosine? Because the angle is with the horizontal. So Fx is going to be the force 10 cosine alpha is equal to Wx. What's Wx? Wx is going to be 10 sine alpha. Why? Because the angle alpha here is with the vertical. Okay, let's see. Can we find alpha? Sorry, why did I put 10? Ya Rabbi. Sorry. Wx is not 10 sine alpha. Wx is W sine alpha. And W is mg sine alpha. What's the mass? The mass is 300 grams, so 0.3. G is 10, right? So 3 sine alpha. So 3 sine alpha. طيب. Let's divide on both sides by cosine alpha. You're going to cancel this. You're going to get 10 is equal to sine over cosine, which is tan alpha. 3 tan alpha. Right? 3 tan alpha is 10. Divide by 3 on both sides. You get tan alpha is equal to 10 over 3. So do shift tan 10 over 3. What you're going to get, you should get 73. So shift tan 10 over 3, 73 degrees. Type. Can we find the normal reaction? Yes, we can. The normal is equal to Wy, which is W cosine theta, so mg cosine theta. So mg, we said it's 0.3 kilos, right? Because 300 grams times g, which is 10, times cosine alpha, so cosine 73. So 3 cosine 73. Also, wait, no. This part is wrong. Because when I wrote this, I didn't write the Fy here. Sigma Fy is equal to 0, right? We have this Fy going up, we have Wy, and we also have the normal reaction going up, صح? طيب, okay. Wy is equal to the, what's down is equal to what's up. So N plus Fy, right? Let's see. Wy we said is mg cosine, that's in this case 73, is equal to N plus Fy. What is Fy? It's the force 10 sine. Why sine? Because the angle is with the horizontal. 10 sine the angle, which is 73, right? So 10 sine 73. So N is equal to mg cosine 73 minus 10 sine 73. mg cosine 37, mg we said is 3, so 3 cosine 37 minus 10 sine 73. Do it on your calculator. 3 cosine 37 minus 10 sine 73. Why am I using, guys, I keep on making mistake, I'm sorry. Why am I using alpha as 37? Wallah. Guys, wallah, these mistakes, I'm not making them make. It's just, I'm not focused. So 73 minus 10 sine 73. 3 cosine 73 minus 10 sine 73. So I just realized you had to do plus, and I'm realizing this now because if you look at this force here and you draw its line of action, it's not above, it's actually under. You see how it's under? So I should have drawn it here. Ya Allah. Too many mistakes, guys. I know. I'm sorry. Whatever. Okay, sorry. But this is mechanics. You're always gonna make mistakes like this. So it's gonna be Fy is gonna be like this, but Fx is still gonna be the same thing. So F is gonna be like this. So Fy is gonna be down. So Fy. So here it's the same exact thing. What's down is equal to what's up. So Wy plus Fy is equal to N. So let me just rewrite this. what's down is equal to what's up. So Wy plus Fy is equal to N. Wy is mg cosine theta. So we said mg is 3, so 3 cosine theta, which is 73, plus Fy is the F10 times Fy, since the angle here is with the x-axis, is the same thing, by the way. What's alpha? 73, so it's going to be sine, since it's y, sine 73 is equal to N, and you're going to get 10.4. Assume now the inclined plane is scratched to make it very rough. How will it affect the value of F? Obviously, to keep the block stationary, there's going to be now more friction. So would you need to apply a force now? No. It's going to be a very small value of F. Several different values of the different horizontal F can be applied to keep it stationary. Which of the following is the best explanation? Because the static friction can vary, right? Remember, to keep it stationary, it's static friction. You can keep it, you can apply different values of F because static friction can change. It always changes. Okay, question 17. An airplane is accelerating at 15 meters per second at an angle of 30 degrees. The weight of the plane is 60 kilonewton. The thrust force is 130 kilonewton. The lift force on the airplane is what? So basically here, the free body diagram, you have the weight going down and you have the perpendicular force going like this, right? Right. So you have y here, you have x like this, right? So let's draw it. X, W, so 30 degrees, you have the weight like this, y-axis, x-axis like this. Okay, obviously it's accelerating at 15 meters per second at an angle of 30. They told us that the thrust has 130. The angle is 30. So that means the thrust is acting like this. Okay, because obviously the plane is going up, so the thrust will be angled, right? Akid, down, we're going to have the x component of the weight, the y component of the weight, and the x component of the weight. Up, we're going to have something that we call, instead of normal, we're going to call it the lift force. Okay, is the thing pushing it up. Okay. Let's call this force T, the thrust. Okay, look here. Is our airplane, is it flying up and down? No, it's just moving to the right, horizontally, right? With the horizontal region. So that means sigma Fy is equal to 0. What are my horizontal, what are my vertical forces? I have Wy here, which is W cosine 30 is equal to everything up, right? So is equal to L plus the thrust, the y component of the thrust, which is T sine 30. Let's solve it. The weight is 60, so 60 cosine 30 is equal to L plus T sine 30, so 130 sine 30, which is 65 sine 30. Let's subtract now, so take 65 sine 30 to the other side. Okay, never mind. So it turns out that the thrust force is a horizontal force. Yeah, the thrust force is a horizontal force. Yes, wow. Okay, this mechanics quiz is actually AIDS. I hate this quiz. I hate mechanics, man. Anyway, is it in red? Yes. Okay, so thrust is to the right. So obviously we're gonna remove this. So L is just gonna be equal to 60 cosine 30. So it's gonna be 52 kilonewton. Using Newton's second law, what is the net force on the airplane? The force, the sigma F net is equal to ma, right? So what is the mass of the plane? 60. The weight is 60. You know, weight is mg. Can we find the mass? We know the weight, we know the g. So 60 is equal to m times 10. So you're gonna get m is 6. So it's gonna be, the mass is 6 times the acceleration is 15, which is 90. The passengers in the plane feel like there's a force directed backwards. It pushes them press into their seat. Which of the following is the best explanation for this mechanical action? Obviously, inertia. Inertia basically means, there's a resistance to every force. Every force that happens, there's resistance. Pushing you forward, that means there's inertia pushing you backwards. Okay? Question 18. A conical pendulum is a long string with a bob of mass 200 attached to it. The bob is set in motion with a radius of 60, a rate of 1.5 revolutions per second. G is equal to 10. The normal acceleration of the pendulum and whatever. Over here, let's draw the FBD. This is the, let's call this the horizontal. This would be the weight, right? This would be the angle here. Okay, and this is the only thing attached to it. Obviously, you might have, no, there's no norm because it's hanging. Okay, and you'd also have the tension like this. Let me make it a bit easier. I'll draw it over here. Okay, this would be the weight. Heck, because it's like changing. Yeah, this would be the weight. This would be the tension. Heck. Okay, this would be the FBD block because it's moving around. Weight is like this. And you have the tension, it's angled, so heck. Okay, so they both have the angle alpha. This is how it looks. Let's now start with Fy/Fx. Sigma Fy is going to be equal to 0 because they're saying it's moving horizontally, right? So that means W is equal to T. صح? So T, one second. The weight is vertical. أكيد it's going down يا أخي. This is the angle here. Wait, I drew the FBD wrong. One map. You have the weight of the pendulum and you have the tension acting like this. This is the angle here, right? طيب, this is tension, this is weight. We know, let me draw it again. هيك, weight, this is Y, this is X, this is the tension, IU alpha. Okay, sigma Fy is 0. So that means W is equal to the Y component of the tension, which is T cosine alpha. Also now, sigma Fx is equal to the mass times the acceleration. We only have one horizontal force here, and it will be the x component of the tension. So T sine alpha is equal to the mass times the acceleration. You can now start substituting. Here, we can change T into divide by cosine. It's W over cosine theta. So over or alpha, whatever. So instead of T, I can put W over cosine alpha sine alpha equals the mass times the acceleration. Now I can solve this very easily because sine over cosine is tan. Tan alpha times W is MA. What's the weight? W is equal to mg. So 0.2 times g, which is 10. So it's 2. So 2 tan alpha is equal to the mass 0.2 times the acceleration. Basically, for this one, you have two unknowns, and you can actually find a n, which is 4 pi squared r f squared. Okay, so 4 pi squared r is 0.6 times 1.5 squared, and you're gonna get, if you go back, you're gonna get this 53.3. Okay, then they're saying the angle the pendulum makes. Obviously, you have this equation, right? So you can just do shift tan. So it's gonna be shift tan. Take the one, the 2 divided by the other side. So it's gonna be 0.2 times an, which we got is 53 over 2, and you're gonna get this. And then the tension in the spring, we got that the tension T sine alpha is MA. So how do we find the tension? It's just T is equal to MA divided by sine alpha, right? So it's gonna be MA, the mass, 0.2 times G, is 10, divided by sine alpha, so divided by sine 79, it's gonna be 10.79 to the nearest integer is 11. Question 19. A person of mass 60 kilos stands on a bathroom scale in an elevator. The acceleration of free fall at the location of the person is 9.81. The weight of the person in the stationary elevator is how much? Weight. W is equal to mg. So it's going to be 60 times 9.8. You're going to get 589. Okay. Rank the readings on the bathroom scale for the instance. Label the instance when the reading is the highest, it's 1. If two readings are identical, give them the same one. Okay. Obviously, it's going to be the highest. You know F is equal to MA. So if A increases, then obviously F will increase. So the reading will increase when you increase in the acceleration. So the acceleration is highest here is here. Why is it not this? Because here it's moving downwards. So the highest one is 1. Then here they're both negative. So before I go to negative, let's see where it's just like no acceleration. Obviously it's gonna be uniformly. They're gonna be the second highest. Then when it's negative, -1 is greater than -2. So obviously its force will be greater than -2. Question 20. Question 20. You have a block of wood sliding down uniformly along the triangular prism of sides 3, 4, 5. The sides of the prism are rough. Which of the following is the free body diagram of the wood? Akid, you have the weight, you have the normal reaction, and obviously since it's rough, it's F. So it's going to be this one. The coefficient of friction is what? Let's take the FBD and draw it a bit. We have, obviously, the weight is acting to the left here. So we're going to call it mg. You have the normal force, right? This is the arrow. Ya Allah. This is the N. You also have the friction, which is acting to the right. Yeah. Let's see. We have Wx, which is mg sine alpha. And we have Wy, which is mg cosine alpha. Obviously, this is alpha. Let's do Fy. Is it moving up and down? No. So sigma Fy equals 0. So mg cosine theta is equal to N. Okay. Sigma Fx. Let me actually substitute this a bit. Actually, let me just from now go to Fx. Sigma Fx is going to be equal to mass times acceleration. Actually, no, it's not going to be equal to mass times acceleration since he said it's sliding uniformly, right? So 0. Sigma Fx is 0. What is my x's? We have x as we have mg sine alpha and we have the friction. So mg sine alpha is equal to friction. Fk. What is Fk equal to? Fk is equal to mu n, right? طيب. mg sine alpha is equal to mu k n, صح? What is n? mg cosine alpha. So mg sine alpha is equal to mu k mg cosine alpha. Can we find mu k? Of course we can. It's going to be equal to mg sine alpha over mg cosine alpha. mg with mg, sine over cosine, mu k is equal to tan alpha. We're missing an alpha. We need this angle over here. We need this angle over here. This angle is equal to this angle. How do we find this? This is 3, 4, 5. It's a right angle triangle. Can't we find this? Let's take the triangle over here. 3, 4, 5. We have the alpha here. Let's take opposite of, let's do sine. Sine alpha is equal to opposite over hypotenuse, right? So 3 over 5. So it's going to be alpha is equal to shift sine 3 over 5. So you're going to get alpha is equal to 53. I think. Is it? So you're going to get, wait, let me do shift sine 3 over 5. 36.86. So 36.86. So go here to tan alpha. So it's going to be tan 36.86. So tan of the answer. What do you get? 0.75. The block of wood is now placed on the 3-meter side of the prism. So they put it here. Okay, the acceleration of the block is what? Let's draw a whole new FBD for this one. If it's placed over here, we have the weight going down like this. You have N is like this, right? So this is X over here. So let's write it like this. Y, X, and the weight is like this. Alpha, what else do I have? Yeah, N, and obviously there's going to be friction kinetic. It's going to be accelerating. Actually, let's start with, we have the normal, right? Let's start with Fy. it's 0. So that means n is equal to the y component of this, so w cosine alpha. Sigma fx is accelerating, so it's going to be accelerating. Fx, so it's going to be the x force here and the x force here. So w, the x, wx is going to be w sine theta, right? So w sine alpha minus fk is equal to the mass times the acceleration. So fk, we know, is equal to mu k n. So we're going to substitute this by w sine alpha minus fk. So mu k, which is 0.75, times w cosine theta equal to the mass times the acceleration. We can cancel mass everywhere. Why? Because w sine theta is mg, w equal mg sine alpha minus 0.75 mg cosine alpha equal to ma. M. You're going to get g sine alpha minus 0.75 g cosine alpha is equal to a. Obviously, you need alpha, you need the angle, right? And like we did earlier, the angle here is equal to the angle here. It's geometry. I can prove it if you want, but no need. This angle here is always equal to this angle here, the same way that the angle here was equal to this one. The angle here, again, it's a right angle triangle. 3, 4, 5. The angle here, opposite over hypotenuse. Sine of, let's call this alpha. Sine of alpha is opposite over hypotenuse. So shift sine 4 over 5. So you get 53. I would say 53.1. Okay, so it's going to be g sine alpha, so 10 sine 53.1 minus 0.75 times 10 cosine 53.1 is equal to a. So you're going to get, oh my god, 10 sine 53.1 minus 7.5, because 0.75 times 10 7.5, cosine 53.1, 3.5. Whoa! Hardest Mechanics AMS. Thank you so much for watching. Good luck.